It was really, really exciting. It was on a huge rocket at the time, one of the biggest we have. It was called a Delta IV Heavy, and I'm really glad somebody told me that when the Delta engines turn on, it looks like something exploded on the pad, because that's what it looked like. And then you see the rocket move up. And amazingly, the reason we needed a huge rocket to get to the sun is it takes many times more energy to go in towards the sun than it does to go out to Mars. And you think, why would that be? Well, so the Earth is actually moving at about 60,000 miles an hour around the sun. And in order to get closer into the sun, you need to lose that velocity. So gravity can get you closer to the sun. And so we actually had to launch into an orbit that actually loses energy over time. And right now, Parker is orbiting the sun. It's the first spacecraft that humans have ever put up that actually orbits around the sun. And the amazing thing to me, that of course, the sun has a huge amount of gravity. It's most of the mass of our solar system. And every time it does a close pass around the sun, the spacecraft goes up to 430,000 miles an hour. Let me say that again. That's nearly half a million
I am
miles
trying
an
to
hour, right?
fathom that because what else comes close to traveling that fast that's in space?
It is the absolute fastest human thing ever made. And like I said, when you go out to asteroids, and if you want to catch an asteroid, you need to get up to say about like 35,000 miles an hour. This is more than 10 times that, as it does a very slow pass around the sun. And as you said, I mean, of course, the sun is the source of all life for us, but we need to be a bit careful about what it throws out. It can throw out huge bursts of charged material, little protons and electrons. And if any of those, if it's a particularly large ejection, it could be damaging to our electrical grids. So it's not particularly dangerous to us biologically. The atmosphere, the air, is very good at absorbing those particles, but it dumps a huge amount of electrical current and magnetic current into the Earth's, into our magnetic field. And that can actually bring down, like I said, power grids, cause blackouts. And we actually work with things like the FAA, the airliners and all of that, to make sure if we know one of these bursts is coming.